It starts long ago and continues today with lots of fire and ice, mountain peaks and ocean waves, and more time than we can imagine. The story begins with igneous rock, like this piece of granite. Igneous means fire. This granite was created in a fiery place, perhaps long, long ago. Billions of years in the past, when Earth was new, there were no rocks. Earth was a burning hot, gooey ball of melted minerals and metals called magma. Eventually, as heat drifted into space, Earth's surface cooled. A thin crust of rock formed over it, like ice over a lake in winter. This crust, made of minerals and metals cooled from red-hot magma, was igneous rock. Some of that original rock formed more than 3 billion years ago can still be found today. It is among Earth's oldest objects. If it had eyes, that rock would have seen the start of life, the making of coal and oil, the rise and fall of dinosaurs, and the world's first person. That rock would have seen it all. Igneous rock is not only some of our oldest rock, it is also some of our newest. Earth has never stopped making it. Somewhere people probably watch it form right now, at the edge of volcanoes. Lava is magma spewed out by a volcano. It hardens into igneous rock. Volcanoes also show us that the inside of Earth is still full of fiery magma, not cooled into solid rock. Igneous rock occurs in many forms. They vary according to the kind of minerals and metals they're made of, and how fast they cool. Granite cooled slowly underground over thousands of years. Obsidian, which looks like black glass, cooled quickly, as did pumice, which floats in water. Though varied, all igneous rocks hardened directly from magma. The second rock of our story is sedimentary rock. Sedimentary rock develops through a long process that starts with weathering and ends with lithification. Weathering breaks down rocks on Earth's surface through mechanical, chemical, and biological forces. In mechanical weathering, heat, cold, ice, wind-blown sand, and falls slowly crack and wear down rocks. In chemical weathering, rock dissolves in rainwater, which is slightly acid. In biological weathering, plant roots both crack and dissolve rocks. Weathering occurs slowly, but old gravestones in cemeteries show what can happen to exposed rock. Over time, even huge mountains weather bit by bit into sand, dust, clay, and minerals dissolved in water and disappear. 200 million years ago, the Appalachian Mountains were several times their present height. Where do the mountains go? They get carried away through erosion. Wind, and especially water, moves each bit of mountain rock downhill. Eventually, eroded rock fills up nearby valleys or gets carried away in a river out to sea. We call the moved material sediments. Wherever they settle, sediments accumulate in layers. In oceans, sediment layers may grow higher than our tallest mountains. Upper sediment layers press down on lower ones. This helps lithification, the process that turns sediments into stone. Sometimes layers get squeezed so hard, sediment grains get shoved into one another and lock into place. Other times, water evaporates from a layer and leaves behind minerals that glue together the tightly packed grains. Either way, what was once sand, mud, or gravel becomes sedimentary rock. Depending on how it formed, sedimentary rock may be quite hard, or rather weak and crumbly. Sedimentary rock may not stay forever where it's settled. Strong forces within Earth sometimes push up rock from the bottom of a valley or an ocean into spectacular peaks and long mountain chains. Once sedimentary rock, or any other kind of rock, gets uplifted, it undergoes another cycle of weathering. Those same strong forces that push rock up may instead push rock down. If the rock gets pushed deep enough, it melts. Some future day, the melted minerals and metals may harden underground or erupt from a volcano to form new igneous rock. This story's third chapter tells about metamorphic rock. Metamorphic means changed. Metamorphic rock may start as igneous, sedimentary, or even another metamorphic rock, but then somewhere deep underground gets changed by heat and pressure. For example, limestone metamorphoses into marble. Granite metamorphoses into gneiss. What once were flecks of black minerals are now stripes or layers of it. The heat and pressure that metamorphose rock is not enough to melt it, but still enough to cause changes. We might compare a metamorphic rock to a hard-boiled egg. This is still an egg, but it has changed a great deal. Many people consider marble to be the most beautiful of all rock. However, even the beauty of metamorphic rock cannot protect it from the forces of weathering. If uncovered, it too will eventually fall as sediments. So these are three rocks: igneous, sedimentary, and metamorphic. Some are as old as can be, others as new as today. In a way, they're all the same, because they all started as hardened magma. But still, each is different because rocks can change.
The rock cycle. Let's start off with igneous rock. We're going to show you how igneous rock can turn into sedimentary rock. Bits and pieces of the igneous rock fall off due to weathering, turns into sedimentary rock. Alright, or the igneous rock can get buried deep underground, go through some extreme heat and pressure, and turn into metamorphic rock. Also, igneous rock can just melt right back into magma, and then when that magma cools, it becomes a new igneous rock. Same thing, sedimentary rock can break down through weathering, bits and pieces come together and make new sedimentary rock. Or it can go deep underground through extreme heat and pressure that doesn't melt and turn it into metamorphic rock, or it can melt and then turn into magma, which will become a new igneous rock. The cycle goes just as follows. Make sure you know this chart. Metamorphic rock can also go through weathering. Bits and pieces can come together in metamorphic rock, and then it's now sedimentary rock. Or metamorphic rock can get buried deep underground like it already is and go through some more heat and pressure and turn into another metamorphic rock. Also, metamorphic rock can melt back into magma and become igneous rock.